So this is the next video lecture, and this video lecture is presented and which is covered in the unit number 4 of repair and rehabilitation of structure. So it is one of the chapter, that is load test on structure. So what is the main objective to do this load test on the structure? The objectives of any structural evaluation are to establish the existing condition of the structure, identify issues affecting the structural performance, and develop and implement any remedial actions required. So, however, in some situations, the results of the structural analysis may not be conclusive, and a high level of confidence in the results cannot be achieved. So, in that situation like this, in situ load testing may be required to gain further knowledge about the behavior of the structure. So then the main objectives, the engineer should clearly define the load test objectives. So to demonstrate that the structure or structural element can safely resist the design loads with an adequate factor of safety against failure, and demonstrate that the service loads do not cause deflections or crack widths that exceeds industry standard limits or preset values established for operation of a given structure. So these are the things that we have to apply in the load test. Then selection of test elements. The portion of the structures or structural elements selected for testing need to be representative of similar areas or elements of the structure, so that the load test results can be exploited to other areas. So we have to choose such that the location of the load test in which the representative of similar areas or elements of the structure, so that the load test results can be exploited to other areas. Then the evaluation of structure during load test. So what are the things that we are going to evaluate? So before that, the loading procedure describes how the structure will be loaded. So load steps required to reach the ultimate test load magnitude. The duration of each load step, loading and unloading requirements, hold period, that is the load, the particular magnitude of load, how long will be hold in the load test. So these all things are to be uh, clearly predetermined in the load test. Then during loading test, we can evaluate the structures, or we can determine the new formation of new cracks, widening of existing cracks, or other damage caused by the applied loads. Then quantitative parameters are those that can be physically measured and can include deflections, strains, angles of slope, and crack widths. Then the applied test load should replicate the effects of the design load conditions, typically uniform loads, then dead weights such as sandbags, then uh, water in containers, or mechanical apparatus such as hydraulic jugs can be used to load the structural elements. So while loading this, while conducting the load test, so we can apply the different types of loads, so especially dead loads. So these dead weights such as sandbags, sometimes we can use these sandbags as such dead weight. Then water in containers, the water is filled in container and that container is being placed over the structures, that will give the load. Or mechanical any apparatus such as hydraulic jugs can be used for loading the structures during loading test. Then structural analysis are to be carried out before and after doing the test. So these are all things are to be done very essentially. So because any load test requires performing structural analysis before and after the load test. The preload test analysis are typically done to estimate the test loads and to determine the load layout. These preliminary analyses also provide information on how the structure may behave during the load test and serve as a check to assess if the structure is undergoing excessively distress during the test. Then the post-load test analysis performed with a better understanding of the actual behavior of the structure, which allow establishing the safety of the structure or determining a lower load rating in case the acceptance criteria was not met. Then types of loads and the instrumentation. So loading using water and dead weights. So this is one kind of a method that we apply the load to the structure. So here the dead weights or water can be used to load the structure element because of the relatively low specific weight of water. The use of containers, drums or cylinders or reservoirs, pools filled with water is typically feasible when the test loads do not exceed 200 psi. So here a figure shows the load test using the drums filled with water. So the container should be free of damage to prevent leakage and stable when loaded to prevent flooding of the test area if a container breaks or tips over. A typical constraint for the use of water is the need for drainage near the test area to dispose the water once the load test is completed. Material with higher specific weights such as sand, bricks, steel plates, etc. can be used when the test loads are higher. Okay, so this is one kind of loading mechanism. Then the other one is loading using hydraulic jacks. When using hydraulic jacks, an adequate reaction must be provided by the existing structure and or steel elements typically manufactured for the load test. Yes, the elements new or existing should have sufficient strength and stiffness to allow application of the test loads without adversely affecting the outcome of the load test. So while using jacks, what we need, so in order to work the jack, here the reaction force is to be given. So that reaction is being taken from the existing structure or new element, so that one should be very strong. The selection of load application method using hydraulics depends on the test load magnitudes, geometry of the structure and field constraints. Then common methods are described in the further slides. So the first one is push down test method. So one or more hydraulic jacks with the extension or appropriate supports are used to react against the structures above to create downward concentrated forces on the test element. So this is called as push down method. So here the figure is given. So what we are given in this case, hydraulic jacks with extension or appropriate supports are used to react against the structure above to create a downward concentrated force on the test element. So this is nothing but push down method. Actually what here the at the top there will be reactive the reaction force is given from the top and which is pushing the jack into downward. Therefore here you see that here this is the element is going to test. So this is the element is going to test and this is the hydraulic jack. This one and this one is the hydraulic jack. So here in which the load is coming from the top, that is reaction load is taken from the this element. This the reaction load is taken from this element. This is this straight element and this reaction load is transferred in downward direction to this member and the load is acting on this member. Okay, so this is the push down method. Then the next one is pull down test method. So the hydraulic jack applies the loading using reaction on existing elements below, such as columns or beams or micro piles driven into the soil or dead weights to effectively pull down the test element. So this is the another figure shows here. Actually pulley is an arrangement pulley is made. So the reaction is taken from these two columns. So this is the loading platform which is given so that the test can be carried out. And this is the closed loop test method using self-reacting load condition within the test component. This method does not require resistance of external reactions. So this is a self-control method. So with the use of this girder, heavy high strength steel bar or steel beam, the reactive force is being given to the jack, and therefore the here we need not disturb some any other existing members like that. So that's why it is called as using self-reacting load condition within the test component. This method does not require resistance of external reaction. Hydraulic jacks applying the load simultaneously to two elements by reacting against an existing beam supporting the test elements. Then measurement equipment and data recording. So the measuring equipment and data recording. So during the test, what are the equipment or measurement that we are going to take, and in which what is the equipment that we use to measure, to take the measurement. So for the instrumentation to monitor the response of the structure during the load test should be carefully selected. However, when we using dead weights, water or dial gauges, data can also be manually recorded at the completion of each load step. So sometimes we are using the dead weights manually with the use of that sandbags and water, that is container filled with water. So in that case we can record it. So the load amount of load is being recorded at the completion of each load step. So that thing is also possible. Then load cells are typically used to monitor the load applied by the hydraulic jacks. So with the use of hydraulic jacks and the reaction loads that we are given to the structure, so that thing can be measured with the use of load cells. Then pressure transducer can also be used to measure the fluid pressures in the hydraulic system, which can be calibrated and correlated to applied loads. Then deflections are commonly measured using the LVDT, that is linear variable differential transducer. One of the accurate the deflections or strain can be measured. That deflection and strain of the member is measured very accurately with the 0.01 mm accuracy. So electrical resistance strain gauges are commonly used to measure these strains directly. So these are all the some of the measuring equipment. So in general, the accuracy of the measuring devices should be as minimum 5% of the maximum value to be measured. Therefore, the engineer conducting the load test should always make preliminary calculation of the values to be measured in order to determine the appropriate instrumentation. So with this, I just conclude the procedure that we adopt to do the load test and what is the purpose of doing this load test. So especially the main motto of this load test is to assess the existing, the bigger structural behavior of the existing load structure. Okay, thank you.